Today we are going to learn how to connect solar panels of same rated, solar panels of different rated. If you connect solar panels of same rated, what is the advantage? If you connect solar panels of different rating, what is the problem? Let's try to understand with an numerical for more clarity. So here mismatch in voltages in a series connected solar panel. So how many solar panels you are going to have? This is solar panel 1, solar panel 2 and solar panel 3 with maximum voltage of 17 volts and maximum current of 5.1 ampere. So I want maximum power. So maximum power is equal to 17 volts multiplied with 5.1 ampere. Perform it. How much it is? 86.7 watts. I have a second module with 16.5 volts. Sir, why it is giving lesser voltage? Due to the amount of solar irradiation is very less, but current is same. I can say that all these three panels are connected in series connection. And what are the ratings of this panel? So this is also of 100 watt peak. This is also of 100 watt peak. I am taking example like this 100 watt peak. So these modules may be each 100 watt peak, one is 80 watt peak and one is also some 120 watt peak. Okay, let's try to see with the example. So here you have the maximum voltage is 16.5 volts and current is 5.1 ampere. You can see here all these three panels are connected in which connection? Series connection. Therefore current is same. So multiply with the voltage. So for the second panel you are going to get 16.5 volts multiplied with 5.1 ampere. How much wattage you are going to get? 84.15 watts. Next one. Third panel is connected with a maximum voltage of 16.3 and maximum current of 5.1. So say this value. So this is 16.3 multiplied with 5.1 ampere. How much you are going to get? Very good. 83.13 watts. Add all these three powers and calculate the maximum power that can be developed when these three are connected in series. 86.7 plus 84.15 plus 83.13. How much? 2. Very good. 8 watt peak. So when you connect these three solar panel in which connection? Series connection. In series connection what will be added? Voltages will be added. So you can do it as per our formula. So in series connection what will be added? 17 volts plus 16.5 volts plus 16.3 volts. So calculate the voltage. 49.8 volts. And already we told that in a series connection what is constant? Current is constant. This is nothing but V maximum voltage of the array. What is the maximum current of the array? I maximum of the array. So in a series connection what is constant? Current is constant. You multiply with 5.1 ampere. Say the resultant power, you will be getting the same. You will be getting the same. Yes or no? Actually individually you added. Now what you are going to do? We are applying the electrical engineering concept. These three are connected in series. When they are connected in series, voltage is added and current is same. Automatically got the same. So with this combination, how much you are going to get here? 253 watts. So when you connect the panels of which rated? Same rated. I am taking an example 100 watt peak, 100 watt peak and 100 watt peak. Now due to non-availability of the panel, I have been selected a panels. One is of 100 watt peak, one is of 80 watt peak, one is of 120 watt peak. And these panels is nothing but panel 1 generating a voltage of 17 volts and current of how much? 5.1 ampere. Second panel is generating a voltage of 16.5 volts and third panel is generating 16.3 volts. One is of 4.9 ampere, one is of 5 ampere. You can see three panels are generating three different currents. Sir, why it will happen? First condition is these three are of three different rating. And one more problem is sometimes you may get trees. These tree branches may fall on the solar panel. When tree falls on the solar panel, the current rating will decrease. Assume that a tree branch has been fall on our solar panel and automatically the current rating may decrease. This may be one more case. First case is reduced rating of the solar panel. If you should not select the panels of which rated? Different rated. There is a wrong selection. Automatically one will be of lower magnitude, the remaining will be of higher magnitude. Next problem is we should install the solar panel where we have 100% lighting parallelly to all the panels. There should not be any obstacle due to tree branches or any shadow. If you have a shadow, that's called a shadow effect or shade effect, automatically the current in one solar panel will decrease. What will happen? Current in one solar panel will decrease. So now I can say that these three panels are connected in series connection. So when they are connected in series, how to find the formula? One is 12 volts, one is 16.5, one is 16.3. So this is 17 volts, 16.5, 16.3. I require the output voltage, which is nothing but the array voltage. Here how many currents will flow? Three currents will not flow. Why? Because in a series connection what is constant? Current is constant. Whatever the current which is of lower magnitude, in these three, which is the lower magnitude? 4.9. Only 4.9 ampere current only will flow. That's the main problem. But 5.1 ampere current will not flow. Why? Because whichever is the lowest current, that will affect the remaining. Okay. Now when you perform, apply the KVL. I am assuming that a current of 4.9 is flowing. Current is leaving. What is the leaving polarity? Positive. So how to apply the KVL? So current is leaving. What is the leaving polarity? 16.3 volts. And current is leaving. What is the leaving polarity? 16.5 volts. Current is leaving. What is the leaving polarity? 17 volts. And current is entering. Current is leaving. What is the leaving polarity? Minus maximum voltage of the array, that equal to 0. So I am sending to right hand side. So when you add it, the maximum voltage of the array is equal to, add these three parameters, 16.3, 16.5 and 17. How much? 49.8 volts you are getting, right? But we require to calculate the maximum power of the array. The maximum power of the array is equal to, the maximum voltage is how much? 49.8 volts multiplied with, what is the current? 4.9 amperes. What is the resultant answer you are going to get? 244.02 watts. So you see here, if the panel is of same rating, if you select, how much you are going to get? 253. The same panel of different rating you selected, the current which is of lower magnitude is changing the power. So now what is the difference? 254 minus 244. How much? How much is the loss? 10 watts is the loss. You are having a panel of required highest magnitude, but how much you have been lost? 10 watts you had lost. Why? Because you connected the panels of which rated? Different rated. But if you connect the same panels of same rated, you are going to get how much extra power? 10 watts extra power. Okay. Why this power is wasted means, first problem is selecting the panels of which rated? Different rated. Next problem is you should not install the solar panel under shadow condition. If one panel is subjected to shadow, this will affect the current development. If the current is decreased, total performance will be depend only on what? Current. Why? Because they are connected in series connection. Automatically current magnitude is decreased. The resultant power generated is also. Now what is the conclusion of the problem? It is recommended to connect the solar panels only in which connection? Same rated, and you are not supposed to connect the solar panels of different rated. And second conclusion is, don't connect the solar panels under shaded condition. So if any tree branches are there, you trim it out, or install the solar panel only where perfectly the lighting is available. So this is what the conclusion of the mismatch in voltage is one problem. Next one is mismatch in current. Now we will try to see about the parallel connection of solar panels.